Yeah, welcome to our first webinar in this year, first seminar in this year from Nuremberg. A very warm welcome, worldwide partners and also customers and maybe also interests who are interested in this theme. Grid transparency in the low voltage grid. First of all, I would like to introduce myself a little bit. My name is Fabian Leppich. I'm the product manager of Power Quality Systems. I'm responsible since 2020, 2021 approximately for this product group in our house. And yeah, I have experience in the field of power quality approximately 14 years since 2010 when I started at this theme. Yeah, who is Eberle? Maybe some of you doesn't know that exactly. We are a company, medium company with approximately 40 years experience in the field of measurement and regulation technology. Most of you are familiar with our regulation products from the back years. And yeah, we were founded in 1918. We are located in the Franken campus in Nuremberg. Approximately, we have in the meanwhile 140 employees. If I look back, the employees were much lower, but in the meanwhile, yeah, we are also in my product group like a startup. You can see that we have extended the products as well as the development part in our company. Yeah, and therefore it's good to have good employees, and yeah, we every year extend our employees there. We have a mission inside, clear communication, clarity, openness, and fairness, and this helps us also to get the good employees for all these requirements which we get from your side and also which we get from the change in the grids. This is our main theme today. We are active at all voltage levels in production, transport, and distribution of electrical energy, and therefore we have several product groups, the regulator system, the power quality, and also a solution, the low voltage regulation, as well as the earth fault detection systems. And all product managers are managing to to extend the market in also worldwide in approximately 65 countries. We are focusing on that, and also there we extend with our partners together the market worldwide. We are awarded every year in the meanwhile, and also on certification. We are also certified due to the fact of IT security. This is one theme which I want to give you also at the end of my small presentation. In case of ISO certification, so IT management, ISO 27000, for example, and also an innovation award we get every year. So 2023, 2024, especially also for the development parts in the field of power quality. We are glad that we are also a Kununu top company in 2024 and 2023. This helps us to get the good employees for increasing the market or for getting good employees. my first slide is about a platform which we also provide. As you have seen, we are ISO certificated, ISO 27001, which is a management tool for IT security. And therefore, we provide you, because we also knew what is necessary to get these certification, and you also need, for example, in case of IT security, an active patch management to get these certifications in case of the critical infrastructure. And therefore, we have founded a platform for patch management. The link you can see there. This is no advertisement. This is only an information about news in the selected product areas, especially in the field of patch management, device management, and also we could deliver then patches over a two-factor authentication download to provide you secure software patches. So it would be great if you could manage to register there, and there, only the product groups will inform you about issues and also about news in the field of firmware and software. Yeah, power quality. What is that? I have one small sketch here, you can see, and for all of us, it is quite interesting to go one step back, because the main theme is the grids are changing, and also, we have to react on these changes, if we understand what happens inside the grid, especially in the low voltage grid, it is good to have such high such sketch. So what can you see on this sketch? Every electronic equipment is an interference source. So if I at my house install or will charge my EV, this is clear that my EV is then an interference source, because due to the fact of the current which my EV is using for charging the battery, the grid is changing. So the grid will react on this current which the charging or the process will need. And on the other side, I have another equipment in my house, like an electric hob, big electric hob. And this electric hob is also must react on that, or should not react on the change of my EV, or the other way around, the EV should not make interferences for the electric hob. And to provide these and to get these stable, general standardization is needed. So EMC standardization is needed. So in the norm group of IEC 61000-3-2, for example, on the bottom here, every equipment worldwide is recognized with what these electronic equipment should make on the grid. So how the grid is changed by these emissions. And on the other way, the electric hob or the EV must also be stable enough to get working, to get still working on these change. And this is the IEC standardization, IEC 61000-4-X. And we, in the field of power quality, we are in between, because we cannot even say if everything is stable, but someone has to control that. And this control mechanism is, for example, an EN 5160 standard. So the product standard of voltage quality, not power quality. EN 5160 only has thresholds for the voltage, because the voltage every device is seeing, which is installed on the grid, and therefore it has to be controlled. So the stability is due to the fact of the signal to noise ratio. So if the signal to noise ratio is very high, it is clear that we have not that much influences from one device to another device and the other way around. So EMC coordination must be like, generally, if the EMC coordination is made good in your country, worldwide, you will not see any reaction. But always think on the history, because in the 70s and in the 18th, when we started to extend the electrical grid generally, and also worldwide right now, Africa, for example, it has to be clear that the equipment and the EMC coordination can only know due these days when the standard will be provided. So we don't know how the future is in the field of the current, for example, and therefore it is clear that the equipment which we already brought in, which we already installed inside the grid, can now be influenced by new technologies which are coming right now into the grid. And this is something I think which describes these small slide very good. Yeah, what is our aim? We want to have, or your aim should be to have a continuous monitoring to ensure the quality of the grid and to create production reliability. So main feature is to measure, identify, and counteract trends and prevent interactions. So it should not occur that a new technology influence old technology, or old technology influence new technology. And to run that stable and to control that, we have the standardization. So the standardization in the field of the grid codes, for example. What are the grid codes? What are the production? What helps us there is the standardization in Europe. We have, for example, the EN 5160 in H voltage systems, in medium voltage system, and also in low voltage systems. This helps us to provide a general stability inside the grid. In the industry, and worldwide standard is available, and this is the whole IEC standardization, IEC 61000-2-4, to prevent these interactions. And there are 3 classes available: class 1, class 2, class 3. And yeah, especially in the European market, we have the so-called grid codes for generation plants, for example, for Germany, Austria, Czech Republic, as well as the Swiss. This is called DACH CZ, for example. But in your countries worldwide, you have also grid codes. In the Asian market, for example, IEEE 519. And what does all these standardization have? You have to know how measures are calculated, because the point is, if you don't exactly describe the calculation methods, if you don't exactly describe how the power quality is measured, how the measures are calculated, it doesn't help you. Because if there are thresholds, the thresholds must be exactly calculated with the same technology. And these calculation methods, the influence of the whole calculation is described in one product standard, and the product standard is here IEC 62586, which exactly describes how measurement technology is must be produced. So under which circumstances, so environmental circumstances, the product have to be stable enough to calculate all these measures. For example, a PQ meter from our side must handle high EMC environments. Clear, because we want to measure in substations, in local grid transformer stations, for example, and there is a high EMC field, and it have the worst thing is that we are influenced by others. So the for example, by temperature, and in the IEC standard IEC 62586, it is exactly described how to manage that inside our measurement technology, to provide what? To provide reliability in case of the measures which we are calculating. Yeah, a new field for us is the so-called feeder measurement, and these feeder measurement, I came to that on other slides. So mainly we are installed between the interfaces, so between, for example, a TSO or a DSO, or we are often installed between a substation, for example, for wind farm, PV power plants, in low voltage grid, but also in medium voltage grid or high voltage grid, to exactly monitor there at this point of the POC, a point of connection, the power quality in general, and how is, for example, a PV power plant reacting on earth faults. This is an interesting question, and our measurement technology helps to understand what happens and helps to provide the grid stable enough there. Yeah, as a summary, we can say why power quality is measurement and technology is needed. We can have with it a predictive fault detection. Problems in the grid can be recognized at an early stage, and failures in the grid could be avoided. We could have the opportunity to get more efficiency, so an efficiency optimization. You can identify energy losses and reduce operating costs. Yeah, one main point is the compliance reporting, and therefore there is a need to have measurement technology which provides the measures in such a good way that they are comparable with others. So it is not said that everywhere an Eberle device is installed, but we have to have a standardization that an Eberle device could be also compared with other devices which are in the market, and we get the same results, and therefore the product standardization is needed. So, and compliance reporting with the regulations in your grid could be also done by this measurement technology, even in low voltage grid as also in medium and high voltage grid. We could have a data analysis and trend tracking, identify trends for better planning and optimization. This is one big point. We even don't know if we now get data inside our database, what these data could be needed for in future to have the possibility to get more efficiency into our grids. And last but not least, protect sensitive equipments. We could, if we run it in a positive way, which means if we react at the right point on, for example, harmonics and supraharmonics, we can extend the service life of all products which are installed at the grid and minimize downtime in general. Yeah, why measure in the local grid? This is an example from Germany, but this is a worldwide phenomenon. The new Bundesregierung have added some big points in our EEG, which is a law in the meanwhile. So we have to shift to renewable energies. This is something which is clear. By 2030, we have to have 110 gigawatts of wind power plus 30 gigawatts from offshore. And in case of PV, we have to make 4 times higher input with PV power plants and small solar power plants and so on. So you can see on these on these numbers that we that we completely change the generation, and that this is not only a German way of could be seen here on these signatures. For example, this is the production or the share of the electrical production from solar and wind until 2022. In the meanwhile, this is also extended more. So Germany here is in front, but all the other countries are also going in this way. And yeah, because of what? Because in the meanwhile, it is much cheaper to reduce the prices in case of using PV than other technologies. So worldwide, the price for PV power plants is decreasing to a minimum. So it is much more efficient for an economical state to go with these technology. And also one big user of electrical energy is coming into our grids. These are the EVs, so the electrical cars. First of all, in China, clear. In European Union, it's a little bit more flat, but these are only examples, and you see here the numbers. They are increasing in a really high way. Why? Because we have to be more efficient, and an EV is much more efficient than another car. So 97% against, I think, 60% or 40% approximately. We have to have lower weights and easier regulation, and all these aims influences our products in the electrical grid. So from the normal asynchronous generator motor, for example, we are using in the meanwhile frequency converters. From the normal bulb, so 60-watt bulb, we are using LED bulbs, and normal transformer, we are using switching power supplies, and this influences directly the currency from these products. So in the back, it was like that an motor or a climate, for example, have these current. We call that internally, it's the McDonald's M current. So this current is an B6 rectifier coming from a classical rectification. Why it is like that? We have here an uncontrolled recharging of the DC link, and so we have a non-sinusoidal current. What is the big issue here? We have a high THDI, a high harmonic fingerprint of 5th, 7th, 11th, 13th harmonic. We change the grid and also the participants in the grid. We are going into the active rectification right now. So what is the aim here? We have here a controlled recharging of the DC linked, so it is controlled. We have a sinusoidal current, but what we could also see that we have an high ripple on this signal coming from the AC/DC AC/DC conversation, from the controlled recharging with a very high switching frequency. What is the big shot here? We have a really low THDI. We are capacitive, but you can see here on that we have a ripple on that. Coming from the first slide from these, or one of the first slides, standardization process is sometimes a little bit slower than the technologies which are coming inside the market. So for us as measurement technology provider, these new technologies inside the grid automatically has influences our development, and so new standardization is needed to provide us from these ripple, and also new measurement concepts are needed in general to identify these things like you could see here, because also here this ripple influences the voltage, and with the influenced voltage you will get interactions in case of heating of other equipments, for example. And good example is if you are maybe some days in Germany or on other train systems, and you are just if you are using your notebook in a train, and you directly if you directly measure the temperature on the switching power supply, you will see that the switching power supply on an ICE train or another train is much, or also on the plane, if you are using that, is much higher than on normal grid. And this is coming from the low short circuit power inside a plane, and also is coming over these ripple on the voltage, which is definitely there. Yeah, an example from my house, which has nothing to do with harmonics, but as you can see here, we are directly inside these changing of everything. So I have nominal load, you can see here, with 0. Then I start a 9 kVA ohmic load here, and you can see this is running here. That's fine. Then I switched off it to nominal. Then I switched on it again, these 9 kV, and at the same time I wanted to charge my EV. And that what happens then? I'm charging I want to charge my EV here, and the EV is not charged in this situation, because due to the fact that the impact of the load on the short circuit power is very high, the EV have to prove the grid a little bit, and it is proving at the first time when the charging process is starting. And yeah, the short circuit power is not big enough, and then the charging will stop directly. And this gives you a little bit the feeling what is happening into our grids in the future. So we have to control that. We have to have measurement technology in the depth of the grid to identify all these issues. If I do it the other way around, if I just charge my EV in the first stage, and afterwards I switch on these 9 kV ohmic load, everything is working. So this is something what also the car producers have to react on, that they continuously have to prove the grid parameters, and to get a stable charging process in the depth of the grid. If you're interested, I can show that afterwards, after this question round, which we have at the end at 10 o'clock. And afterwards, I will show that live. So if you are interested in this live view, you can take part afterwards. Yeah. Directly at the local transformer stations, we have new requirements because of all the things which are happening. There is often no or a little measurement technology installed. So with low technology, it is mostly not with a SCADA connection inside. We have a lot of stations, a lot of local transformer stations in the grid. and therefore a requirement is needed. It has to be much simpler to operate all these maybe needed measurement technology in the low voltage grid, and therefore the measurement provider, so the measurement technology provider like we, have to deliver easy to control, easy to install, easy to handle measurement technologies to run up here and scaling effect in the depth of the grid. Yeah, what is the path of to transforming the energy grids? Yeah, we have to upgrade the lower grid levels. In the grid of tomorrow, measurement control will take place locally, primarily in medium voltage and low voltage station. We have to extend the grid transparency with digital grid stations, digital grid transformer stations. We have to add more measuring points. They have to be networked. We have to make a condition estimation, a grid planning, asset management. All these parts of the utilities have to make their decisions on good measures which are coming from the low voltage grid. As an outlook, we see this is not an outlook anymore, but it is still available, but not that often. We see that in the future, the transformer stations are the local stations for remote switching, for more dynamic grid operation, and therefore a lot of stations have to be control-able for the future. And yeah, at the end of the day, it could be a way, maybe in other countries, it's much easier than in Germany due to our regulation. We see that an autonomous grid operation could be the way for the future, because we have generation and we have also production, and we have also the use of electrical energy in the depth of the grid. So it could be a way to be there autonomous. Yeah, how to do all that and how to do all that, this is a main question. The answer is coming then. Why it is a need to extend the measurement technology also on the local grid transformer station with more or less high measurement technology could be seen here. Non-linear loads in the local transformers are present and are continue increasing. Fault tripping of circuit breakers are present and are known. We have more harmonics in currents, and they are ending at more power losses. So we have overheatings, faster aging, and corrosion of local transformers. They are possible. We can see that in the industry grids because the industry is much faster than we in the utilities. And what also a thing is, the DC components in voltage and current are also increasing due to new technologies. So we have always an AC with a small DC on that, which ends in the corrosion, which could be seen at the local transformer stations. So the asset local grid transformer station is the center of the energy transition and should be protected and should be controlled. And a PQ monitoring system with a feeder monitoring helps to recognize trends and helps to run the grid stable in the future. We don't say every local transformer station must have the high-end technology, but we have different ways to do that. We have, on the one hand side, we could have a transparency with our mobile measurement technologies like PQSys. If you're interested, please let us know. We have the opportunity now with the fixed installed units with simple and easy to install measurement technology at the local transformer station, either with an opportunity of our own feeder measurement or also with an opportunity with external already installed feeder measurements. And we have now a partnership with Vago to provide the autonomous grid a little bit better. Vago is, I think, a really well-known company from Germany, and with them we have a concept to make intelligent control-able transformer stations with added values. For example, an energy management. What is it? For example, if you have an high EV charger, for example, which is installed in the quite next to the transformer stations, we can manage that we bring the data for the energy for the energy flow to control the charging station, for example. But one thing have to be clear. I forgot that, sorry. One thing have to be clear. All the data must flow into one data lake, and therefore we provide a software which is called WebPQ, WinPQ, which helps you to identify and to control all these values. Also for the future, if you don't know how the situation is right now, you cannot see how the trends are going on in the future. Yeah, grid transparency with our technology is what are the aims, what are the main functions. It has to be easy to install and to integrate. So a quick and easy, safe installation on site without disconnection of feeders, plug and play, low wiring effort, also in retrofit, fast and easy integration into the database system. It has to be reduced to the target. The issue is in the low voltage grid that the current in the so the current carrying capacity is the problem, even in industry in low voltage. So we are monitoring there the minimum, maximum, and average values of the current of the feeders. Yeah, it has to be compatible with either our technologies, but also with other technologies which are already installed, and therefore you have to have open interfaces, open protocols, and yeah, an opportunity to also collect data from other sources. This is also one big aim, and to provide these data to different other data lakes, not only to our own data lake, WinPQ, WebPQ, but also to other third-party data lakes, maybe from the grid operator itself, SCADA systems, for example. And we have to have an opportunity to protect, to monitor the local grid or transformer asset with these high-end power quality measurement. Here are some examples from installations with this so-called iSense technology. There you can see the device here in directly installed at the cable with Rogowski coils, which are measuring the current, and the devices are installed in a daisy chain, really easy, and the master is installed directly at the local transformer station and is evaluating the data, is measuring all these data, and the data is stored firstly on these devices itself, and after some days, some weeks or months, because we have an internal and very high-end internal memory, we can store a lot of data inside our devices. After weeks, you can connect the data to a database system. Here are just some examples from different installations which we have done with customers already, where you can see exactly how this is working. So we have from the main function our device PQDA Smart. We have then a daisy chain with iSense 3, iSense 4, which is also provided by us or could be provided by us. And the master, so our technology PQDA Smart, is collecting the data from all these devices which are in the depth of the transformer station, so from each feeder. And the device is possible that we store then over 50 weeks of data from all these feeders and so on. Yeah. What is the technical data of such iSense technology? It is available as a 3-phase system as well as a 4-phase system, and it has a measuring range 1 until 450 amps as true RMS values, and the protocol is open, so it's a Modbus RTU. This is needed because of what? Because of these things. We often have at the feeders third-party components which we can also add to our main device, to our PQ device, which is monitoring the transformer directly. And we also have then the opportunity to measure transformer temperatures and all these other things which are needed to to run up to see the reaction even from the climate change, so the heating effects of a transformer, but also the effects of harmonics on the temperature of the transformer station. This could be also an opportunity. It is prepared for the future in our point of view, because with this technology, PQDA Smart, PQIDE, we have the opportunity already to measure these supraharmonics, which I have shown you in the first slides. So these new technologies which are influencing directly the voltages, and which are often flowing also not only over the lines but also over the earth. This is something new which is coming from all these filter technologies and could be also influence the transformer station. It has to be open not only on this side but also on the side in case of OT technology, so in case of data data communication, and therefore we provide several protocols, open interfaces like 61850, 104. It's more an European protocol, Modbus TCP, which is used worldwide, a new protocol which is called MQTT, or also a new web server API, REST API. If you have questions regarding protocols and all these standardizations, opportunities, and so on, please come back and ask us. We will answer all these questions. The good thing is you can reduce the measurements which have to be transported to maybe SCADA with standard protocols, but at the same time, we have an opportunity to transport all these data very securely, also with a very, very low bandwidth, which is needed. There are technologies on the market which needs, for example, to provide all these data. 1 gigabyte per week. We need 5 megabytes per week. This is clear that this influences also the communication technology which is used, because this is in the local transformer station, it is not that easy to have a stable communication, and our protocols which we are using for transporting all these power quality metering data to our database where all these evaluations are made has very low we don't need so much bandwidth transfer all these data. So don't have fear to measure power quality at the low voltage grid transformer station due to the fact of high data transfer rates. This is something, sometimes you can read that, but this is something which have to be done by the producer of such equipment. And believe me, we have 20 years experience in the field of power quality, and therefore we know a lot of communication with low bandwidth and so on. And we have we have made a lot of depth in this direction to transport also disturbance fault records with 40 kilohertz very easy with low bandwidth to our database system. Yeah, what is in report? What could be in reporting? You have seen we have in the field of power quality a lot of data which we produce, clear, and with very low bandwidth we could transport these data to our database. But what helps it? But what for? This is the main question. We want to have a really easy reporting system, and this really easy reporting system we are developing in the meanwhile with the so-called WebPQ visualizer. And if you are entering the system WebPQ visualizer, you will get on a page which is called Grid Overview. You see all the transformer stations. We have customers, more than 1,000 devices at one page, and there you can just click on one device. You can just sort due to several measures. Here, for example, the H9, the ninth harmonic, and if it is red, this means it is quite near to the threshold, and if you're clicking on that, you are coming from these very abstract green and red heat map to the level time diagram, to the raw data set, and this is available for a lot of measures in the field of power quality and also in the field of fault recording. So even our devices have opportunities to do fault recording, so 40 kilohertz or true RMS values, which we can measure and also store inside the device, even triggered by external binary inputs, binary outputs, but also in the field of we have opportunities of a lot of own triggering, like frequency change, load changes, and so on. Dips, swells, interruptions, and so on. And this could be seen here. So at this week, for example, my devices at home have seen here different disturbance fault records, and if you're clicking on that, you are coming in the depth of the data. Yeah, what does transparency mean in the field of feeders? Yeah, there we have such reporting, such a ranking of the minima and maxima. You have the opportunity to make limits for fuses, and also your own limit settings for the feeder measurement, and also in such reports, and reactive power and energy reporting is an opportunity. With which technology we could provide that? Yeah, with the PQSys Smart, which is a Class A device with always a disturbance fault recording. It is easy to install and to integrate without any PQ knowledge, and this is a need to have functionality because we are scaling in the depth of the grid really much, and therefore it have to be an easy device. So if you at this display, if you click 10 parameters, like for example the current transformers settings you have to enter, the IP settings you have to enter, and that's all. And then the device is monitoring by its own at the installation place everything which is needed, like in black box. You can also describe the whole PQ system of us like black boxes, even for the industry, really interesting. If you install such a device, you don't need to have a continuous data read out, because the device itself without a feeder measurement have the ability to record data over 140 weeks without any leak in between in the long time evaluation period. We have a free software which is coming with the device. This is mostly used by customers at the black box application, which is directly if you have only one wind farm, one charging station, for example, for a big charging station, or also an industry company. If this industry company has processes which are reacting on dips and swells, very sensitive, you can use these software WinPQ Lite for make short evaluations. And last but not least, one big shot at our technology is the security by design technology. So we have, I will show it on another slide, we have the devices are coming with the latest security regulations, applications which are needed. The PQ IDE is mainly the same technology, same firmware. It is a little bit more precise. We have here a 5th current input, especially for the black box application, a bigger display, 144 technology there. We could provide their sensor inputs for current and voltage measurement, and this device have more binary, more relay outputs for evaluating third-party system which could be triggering our device. In the field of IT security, as I explained, we are certificated by our own, not by our own, by TÜV Rheinland, but we are certificated with ISO, and this has nothing direct, this influences not directly our products, because this is just a management certification, but we know what is a need to have, and a need to have in the future is in user rights management with role-based access control. A need to have functionality is radio support for having the opportunity to regulate the users on the device itself. A need to have feature is an audit logging, which exactly logs every user parameter switch and so on and so on. This could be made directly in the device, but also could be provided via open protocols, for example, syslog for your centralized security systems. In the meanwhile, we deliver signed firmware updates, so that it is not possible that someone else extracts firmware directly on the devices by its own. So they have to be signed in the future. We have the brute force detection system and our own data transmission to our, which I already described before, is encrypted with the latest standardizations, and there, we have many opportunities to transport the data in a securely way. If we should use unsecure protocols like Modbus TCP 104.61.850, we are able also in the meanwhile to encrypt also these unsecure open protocols with an VPN directly end-to-end. So no more need of another system is needed. In the past, it was always like that you need to have their own modem technology, for example, which makes a VPN. With the new devices, it have to have an end-to-end encryption in our point of view. And last but not least, due to the fact that we are ISO certificated, we have a certified development and release process. We are proving our devices against OVR-SP top 10, and we have an automatic supplier management for all the equipment, for all the IT equipment which are using there. Yeah. Last but not least, all the data have to be evaluated, and therefore we provide in the meanwhile an on-premise web server solution. What does on-premise means? This is something which is installed. This is a database software which is installed on your site. It is nothing to has nothing to do with a cloud system. It is have a cloud opportunity, but a lot of customers have their own clouds. In the meanwhile, they are using the cloud opportunity of the software. We think that both is needed, but the changes like that the critical infrastructure is due to the political reasons worldwide is going in that direction, that utilities should have the data at its own, so in their own secured OT environment, for example, and therefore we provide this software, WebPQ, for analyzing power quality and disturbance in a browser. And yeah, there are many opportunities, and also one big shot and one big opportunity is here the REST API for flexible data exchange in your organization, because this is needed for the future to run the grid stable and to save energy, and also to have the opportunity to control all these values like supraharmonics, THD, frequency, the voltage itself, either in case of predictive, but also in the case of failure. And now, yeah, I'm at the end of my short presentation, 1 hour. It is hard to bring everything into 1 hour with examples and all that other stuff, because it's such a huge theme. It would be great to get in touch with you to answer your questions regarding local transformer stations, but also general way in the field of power quality. And now I'm switching to my colleague, Max Sefts, who will now ask me questions regarding what you have entered in the chat. Thank you very much.
Thank you, Fabian. I hope you can hear me loud and clearly.
Yes, for sure.
Perfect. Okay. First of all, thank you for the questions in the chat function. If you have further questions, feel free to ask, and we will now in the following Q&A answer all your questions. So question number 1 would be, what overvoltage category are these devices? Are they Cat 4?
Yes, they are Cat 4 300 volt directly. Can be seen here on this slide. I jumped over this slide a little bit due to the time, so the highest category for low voltage, you can directly install that without any fuses in between. That's okay. Mm-hmm.
Thank you, Fabian. Then we got a couple of questions from Melbourne. Question number 1 would be, how do the voltage and current IEC 61430 Class A accuracies compare with, let me check, IEC 61869? So how do IEC 61430 for 30 Class A accuracies compare with IEC 61,869.
61,868-9.
No, it's just numbers. It's
Okay.
61869, the second one.
Okay, I think I will answer this question directly. Maybe we should, because this standard, I'm not familiar with it, if I get that now correctly, but I will check and I will let you know. In generally, the point is that mostly all standards worldwide which have to do with the power quality theme have to are recognizing the 61,000-4-30. The accuracy is not that issue. So accuracy is 0.1% from our devices, which are we are mostly under these accuracies. So we have a higher accuracy than needed, especially in the field of harmonic measures. But the point is more or less how to calculate the measures. And if you have interest, we had last week another web meeting where a colleague of mine have explained the calculation methods really fine and really good. So we can also send you a link for this old webinar, maybe if this helps you. Yeah.
Yes, already noted. We will send this in the official follow-up after the event, and every participant will receive this follow-up mail, and we will link the webinar which Fabian referred to.
Mm-hmm.
And the third question from Melbourne, from the city of Melbourne, was, what harmonics are injected by EVs?
Yeah, generally, I will switch to one slide. So an EV, this could be not exactly said, but generally an EV is not charging like that. So and from an EV, you will not see a 5th and 7th, 11th and 13th harmonic. You will see supraharmonics in the field of 220 kilohertz approximately, and also higher harmonics. For example, the Mitsubishi Outlander, if you are directly measuring at the Mitsubishi Outlander, you can see frequencies up to 50 kilohertz. For example, we also provide here a lot of examples in our white papers for EV chargers, which we can also provide to you. My car, for example, I have an Audi Q4. The charger has a signature as 25 kilohertz. Mercedes-Benz, for example, I know some chargers which have switching frequencies to 10 kilohertz approximately.
Thank you, Fabian. Next question is, what is your approach towards current measurement? Do you see a Rogowski coil as a superior technology, or do you also embrace conventional current transformers?
The answer is not easy to and general answer is, in my opinion, not possible due to the fact of the physics behind. And Rogowski coil is really good and really great in the meanwhile to measure higher harmonics, especially supraharmonics. So there we have a signature. So from the physical principle, it is possible to measure with an harmonics really high harmonics, so the supraharmonics, and to measure the absolute value in 50 hertz. In the meanwhile, it is also possible to measure it with Rogowski in a 1% accuracy. Also not that problem. What from the principle a little bit an issue is with a Rogowski coil is the jump of current. So if I have, for example, to measure the reaction of dips and swells in the grid in case of faults. So if I'm interested in the highest value in case of a fault, then a Rogowski coil have some, because they are measuring from the magnetic flow, more reaction time, and so I cannot see the highest value. But the point is, I can see these jump really good, I think, but not the highest value. The point is, a normal current transformer, if I'm interested into measuring supraharmonics, is not transforming the data from an EV, for example. So an inductive CT has always the issue that he will not transfer these so-called supraharmonics on the secondary side. So even if our device is then really accurate, we can only measure the accuracy which we get from these things. So the answer on the question is, you have to decide, I think, on your application which transformer should be used. And Rogowski coil has many other, I think, big advantages, like it is easy to install. You can make it also in already installed transformer stations really easy. And this was for us the decision to use the iSense with Rogowski coil.
Thank you. Another question would be, what interval and which and how many values are logged in the mentioned 5 MB per week recording?
This is approximately 800 measures, and the most measures are harmonics, supraharmonics, min-max values, power, frequency based on 10-second values. If you need exactly the template which I mentioned, we can also provide it to you. Just write me an email on that, then I can send you the whole list which measures are inside. Because the main thing here is if you measure, for example, 1 year, there are opportunities to identify also over 1 year data the minimum and maximum values for harmonics, for currents, for power, and so on in a bigger interval, in a bigger measurement interval. But mainly inside this file or inside this data object, we have in the EN 5160 values.
Mm-hmm. Then we got a little more general question. What are the standards for harmonic measurements?
This is coming from our products, and a really interesting question. So in 61000-430, there is a remark how to measure the harmonics, and this is IEC 61000-4-15 or -4-7, and there it is exactly described how to do that.
Mm-hmm. Thank you. And then we got Are you finished with the answer? Yes. Okay. We got another question. I think it refers to, could be slide or picture 14. It says, as shown in picture 14, perhaps slide 14. Is it possible to write in a perfect? Thank you. Is it possible to write in a description on an event as an event, as you have done direct in your software? Is it possible to write in a description on an event, as you have done directly in the software?
This would be really good if the software automatic over maybe AI writes directly if this is meant due to the signature of the current, maybe, or also of the harmonics, directly the answer. But I think it is described by this description right now that it is impossible. Maybe another point is sorry, is meant. I will just switch to the software, then I can then you can see that. Maybe also you mean, or the questioner is meaning here, and the thing which could be also done here, and comment box. So, and yes, in comment box is possible. So you can do here in free text, for example, add one, add one slide here, as can be seen here, for example.
The person asked, now added something to the question. He says, now it's no, he means when you know what has happened. So he means perhaps in the past, can you flag events with a description or title or something?
Yes, you can flag events. I can show directly with some information. I will show if you are interested. To just 1 second, I will, like here, and true RMS record, for example. If you have something, you can go to the Analyze cockpit, and in the field analyzation, you can add here comments like, for example, a dip due to external effects or something else like that. You can add a priority, save that, and save that as well to an tab, which is here called live data. And so you see every time these comment in the table here as well. You can find all these comments inside tables and make your reporting on that.
Thank you, Fabian. And then the last question is, can you share some documents for harmonic measurements? And this perhaps I can answer. Yes, we can do that, and we will. So as mentioned before, we will send a follow-up email to all participants, and we will also once link the video recording of today, link the webinar which Fabian mentioned earlier, a few minutes earlier, and also we will link some technical reports about power quality measurement, harmonics measurement, so that you can read everything you're interested in. We will send it with the official follow-up. You should receive it today or at the latest tomorrow. Okay, that has been all questions. Everything that comes in later, we will answer personally if there are still questions.
Great.
Arising.
And now and try to all these persons who are interested how my house is working. It's just, for me, it's the first try to do that live, but you can see here our software, which is doing a live level time stream right now from my house, and then I can show you live, but I have to go to my EV charger to switch that on and off, how the grid is reacting. So if you are interested, it would be nice to do that with you together. As I said, it is a live demonstration and hopefully everything is working, but we will try. I can switch on my EV right now live directly with my mobile phone here, the charging station. So I can go to another charging aim. So 100%, and then you will directly see then the reaction based on these higher load, hopefully. It says it is sending the charging. I tried that several times in the morning, but I'm also that's interesting. So now my app is not working anymore. Hopefully, I think you can see that I have no different charging. I will close everything. Maybe it's working again right now.
Fabian, perhaps in the meantime, there was another question that could be interesting that arose in the chat. I'm not sure if I write it if I read it correctly, but if not, just interrupt me. Power disturbance recording of transients at up to 24 could be milliseconds or US. Don't know what it
Microseconds.
says. Yes.
Microseconds.
Yeah. There's a U in the chat, so he means microseconds. Okay. For this
Microseconds.
speed transient, the trigger setting parameter for one channel only, or for all channel inputs. So can repeat power disturbance recording of transients up to 24 milliseconds, comma, for this speed of the transient, the trigger setting parameter for one channel only possible or for all channel inputs.
You can select and deselect the parameters for every channel.
Thank you. Question answered.
Okay, now it worked. Now my EV is charging, as you can see here, and you can see also the power which is which has increased. So now with everything fine, my EV is now charging, so no issue on that. I will stop now the charging process. I will stand up and go to my electric hob and will switch on my electric hob because this influences my charging process. Just 1 second. I have to jump. So as you have to see right now, I have added an ohmic load of 9 kV without charging. So yeah, could be seen here right now. This 9 kV is now powering up, and now I'm adding the charging of my EV again. So I send a new charging aim. Yes, and the direct reaction you can see here that the charger is starting here and is stopping and is starting and then will automatically stop again. And this is the issue here where you can exactly see the influence of two different participants inside the grid. So in the future, I think it will get a little bit crazy because we have to have new technologies in the grid. Even the charging must be better. Even the ohmic load must be better. Have to control more the local grid a little bit. And this today it's not that sunny because if my heat pump and my PV power plant is also injecting power, I have there also interferences in between. And therefore, I think it is a need if we put now metering technology into the depth of the grid, that the metering technology which we add there have to have a fault recording as well to find out what the reason of such things is, as well as prepared for the future in case of measuring supraharmonics.
Can we, Fabian, there was another question. Can we show the supraharmonics at the same time now?
We can do that, but the point is I cannot see that on this measuring point where I've installed the device right now. This is one big disadvantage of the installation place here, but yeah, generally yes, it would be an opportunity there. Okay. Okay, I hope you have seen what's happening there, and maybe we can keep in touch. We can get in touch. Please send me emails if there are still open questions. Thank you very much And maybe some of you are also participating today in the evening at 16 o'clock, or I think. So if maybe there is
It's
an
5
interest
p.m.
of
Yes, 5 to 6
5
p.m.
p.m.
CET.
Yes.
Yes.
So if you have colleagues who are interested, they can also participate then. Thank you very much. And yeah, best wishes from Germany. Bye-bye.